Okay, the first part is set up equation of straight lines. So on your notebook, please help me to draw the xy axis. Afterwards, please help me to draw a straight line. So, for setting up equation of straight lines, two values that we have to know. The first is the slope of the equation. I represent it as m. For the next information is we have to know a given point on the straight line, and we call it as x1 and y1. And we know that if it is a straight line for any point x and y, with this given point will form a constant slope. So therefore, y minus y1 over x minus x1 will keep in the same value, that is the slope of the straight line. So if we multiply the denominator, we move the denominator to the right hand side, we can get that y minus y1 equals to m times x minus x1. And this is the equation of straight line. In chapter 4.2, it is about general form of equation of straight line. So basically, we can express the equation of straight line in one way, that is y equals to mx plus c. And we call this slope intercept form. And there are two information in this form. The first one is the m. It represents the slope of the equation of the straight line. And for this c, it represents the y-intercept. And in this section, we try to convert it into a new form, that is ax plus by plus c equal to 0. And we call it as general form. I can give you an example. Y equals to 4 over 3 x plus 1 over 2. So for the first step, we will multiply both sides with 6. And as we can see, the denominator, we have 3 and 2. So we try to multiply both sides with the common multiple, the LCM, of the denominator. So therefore, we get that 6y equals to 8x plus 3. And finally, we put the 6y to the right hand side so that it will become 8x minus 6y plus 3. And therefore, it is the general form of the equation of straight line. So basically, there are two rules for setting up general form. The first rule is it must be equal to 0. And the next will be there must be no fraction in front of x, y, or even a constant. And then we can consider ax plus by plus c equal to 0. And this time we try to convert this general form back into the slope intercept form. So therefore, by is equals to negative ax plus minus c. And finally, we divide both sides with b. We get that negative a over bx minus c over b. As you can see, now it is the slope-intercept form. So this negative a over b is representing the slope. And next, this negative c over b is representing the y-intercept. And finally, we want to find the x-intercept. And we will use the ax plus by plus c equals to 0 again. And for the x-intercept, we will put y equal to 0. And therefore, ax plus b times 0 plus c equals to 0. And ax equals to negative c. And x is equals to negative c over a, which is the x-intercept. And therefore, if you memorize negative a over b, negative c over b, and negative c over a, we can find the slope y-intercept, and x-intercept of the equation of straight lines. And below, you can use the figures to identify these values. I randomly draw a straight line and I mark it x. ax plus by plus c equal to 0. And the slope is negative a over b. And the y-intercept is the intersection between the y-axis and the straight line, so it should be in blue color, so negative c over b. And finally, the x-intercept is the intersection between the straight line and the x-axis, so it is negative c over a. In chapter 4.3, it is about intersections between straight lines, and it can be further separated into two parts. For part A, it is finding the coordinates of intersection. So on your notebook, you can draw the figure. First, we have the xy axis. And then on the coordinate plane, you can randomly draw two straight lines similar to this. And I mark it as L1 and L2. For L1, we will consider the equation as a1x plus b1y plus c1 equal to 0. Similarly, for L2, we have a2x plus b2y plus c2 equal to 0. So in this section, we are going to find the intersection between these two straight lines. That means we are finding the coordinates of the overlapping point. That is here, the red in color. You can mark it down, and then I will mark it as P with the coordinate x and y. So again, this point is both belongs to L1 and L2, and therefore we have two equations, a1x plus b1y plus c1 equal to 0. And for L2, it is a2x plus b2y plus c2 equal to 0. And they are equation 1 and equation 2. So in this section, the technique is solve simultaneous equation. And then, let's move on to the part B. It is determine number of intersection. And we know that there are total 3 cases. The first case, the two straight lines L1 and L2 intersect at one point. So we can conclude that there is one intersection. Mathematically, we will use the slope to identify it. That is, the slope of L1 is M1 and the slope of L2 is M2. And because they are two different lines, so that means they have different slope. And for case 2, it appears in two parallel lines. And I use arrows to represent their parallel. And I mark it as L1 and L2. So as you can see, these two lines are separate together, are separate. So we know that there is no intersections. But in mathematically, first we compare the slope, M1 and M2, and we know that M1 is equals to M2 as they are parallel to each other. Then we have to consider the y-intercept C1 and C2. As you can see, they are at a different point, so we know that C1 doesn't equals to C2. So using these two information, we can identify there are no intersections between these two straight lines. And finally, for the third case, okay, that is one line. The two lines overlapping with each other. So we know that these two lines are parallel to each other, M1, M2. So we know that M1 equals to M2. While when we look at, or when we consider the y-intercept, they are still the same. So therefore, C1 is also equal to C2. So using these two information, we know that these two lines are exactly the same. So we can draw the conclusion that there are infinite number of intersections.